Alright, here we go. Welcome to Chapter 5. Congratulations on making it through solving equations and whatnot with Mr. Kelly. This is Mr. Bruss coming back at you for Chapter 5 on graphing. So here we go. Will I Am, there he is over in the corner. Stop by because he really likes algebra and he likes Chapter 5. It's all about graphing. This is a great chapter. He's fired up. Here we go. 5.1. That's right, Will. This is section 5.1. Alright, I got you. 5.1. Alright, let's get ready. 5.1 plot points on the coordinate plane.
Get ready for the showdown. Get ready for the showdown. Yo, it's about to go down. Yo, it's about to go. In the building and I'm here to motivate ya.
Alright, little black eyed peas to get us fired up, get us started here, getting ready for it. Let's talk about the Cartesian plane, named after the famous mathematician Descartes. It's our normal plane that you've probably plotted points on before, so I want to make sure we have all the vocab we need, so please jot this down so you can have it. Let's start with this. This line over here is the x-axis, so a lot of times we're going to label it with units. It's the horizontal. The x-axis is the horizontal, so what is the vertical axis? That's right, it's the y-axis. So make sure we can identify both the x and y-axis. Where do they intersect? Where do they cross? Right here at point 0, 0. Well, what is 0, 0 really called? It's called the origin. It's like where everything originates. So please know point 0, 0 is the origin. So we've got the x and y axis, we've got this origin at 0, 0. So how do we name points? These are called coordinate points. So that's why it's the coordinate plane. We're going to name coordinates. So how do we name coordinates? It's nice and easy. It's x comma y. So we're going to go in the x direction first, then we're going to go in the y direction and plot our point. So that's why we have this x and y axis. It's showing us a direction. So if I pick any point, let's pick B for the black eyed peas. If I want to plot this point, I can say something like this. I'm going to go -2, comma 3. So what does this mean? In the x direction I'm going -2, so on the x-axis I'm going over -1, 2, and then when I'm going up 1, 2, 3, put a dot here. I shouldn't have put those other dots. Let me erase those. The only dot I want to see, you can count, but don't put the dots there. The only dot I want to see is this finished product. This is point B. That is point B right there. Awesome. So something else that kind of helps us. So this would be going in the negative positive direction. So I go negative and then I go positive. So I go negative positive. So what about down here? What if I pick P for peas? What if I do negative negative? Oops, negative negative. -3, comma -4. Well, I want to be able to identify these different quadrants. Quad, think of like quad runner, it just means 4. I've got these 4 quadrants. So where are these quadrants? I can see it's divided into 4 chunks. Here's how we go about naming it. The top right quadrant is called quadrant 1. The top left is quadrant 2. These are Roman numerals here, by the way. So there's quadrant 3, and this is quadrant 4. So if I do something that's -3, -4, if I go negative, negative, 1, 2, 3, 1, 2, 3, 4 in the negative direction, I'm down here. What quadrant does P fall in? It falls in the 3rd quadrant. So if you have a double negative, you're going to be in the 3rd quadrant. B fell in what quadrant? Sure, it's in the 2nd quadrant. Would you freak out? Let's go E, even though it's black peas. It's supposed to be black-eyed peas. I'm out of order. Would this freak you out here? 0, 5. Can you plot this point? Sure. Where's 0, 5? You go over in the x direction 0. You're just going up 5. So 1, 2, 3, 4, 5. Are you in a quadrant right here? Well, you're kind of in between 1 and 2, so we're not really in a quadrant. Where are we really? We are on the y-axis. So make sure you're good on these. This will be in the homework and on the mastery check. I want to know what quadrant are you in. If you're not a quadrant, what axis, or maybe you're on the origin. So this is the key to the Cartesian plane. This chapter is all about graphing, so we have to be comfortable plotting points before we can start graphing lines. Excellent. Let's get rolling with this.
Alright, if you're a little bit ahead and you want to play Battleship to help you plot points, check out the video at the bottom, and I think it is going to have a little link for you too to check out. If not, just power through if you feel good at plotting points. Excellent. Alright, here we go. So what we're going to do is we're going to start looking at points on a line, and I don't know, so I've got this fishing line here. I thought we'd pick points off this fishing line. I had this buddy in high school always said going fishing. I don't know why I said going fishing. I couldn't pronounce his G's and H's apparently. So let's go fishing for some points. I think the easiest point to see right off the bat is maybe right here where it's crossing the y-axis. So this is a good one to start with. What are the coordinates of this point? Well, it looks like I go over 0 and up how much? 1, 2, 3, 4. So this is a possible point. So I could say there's a point on my line. Where else does it hit? It looks like it's hitting at fractions. Not real nice. Right here it looks like it hits. This is a nice friendly point. So how far over is that? Looks like it went over 1, 2, up 1, 2, 3, 4, 5, 6, 7. So it looks at negative 2, 7. There's another point. Any other points? Ooh, it looks like it hits nice here. Looks like it hits nice here. It's nice here. And there. So I can maybe, let's do one more. 2 and 1. So I can name all these points. If I start to go into fractions, I don't really know. Is that over 3 down a half? Maybe, maybe not. So I'm going to stick to ones where I know exactly where it hits. So I know it hits at 4, negative 2. So these are all points on my line. Another way to represent this, what we're going to use a lot here, let me change colors, is make it a table. So we're just going to say, well, instead of putting all the coordinates, I'll just say x and y. When x is 0, y is 4. When x is negative 2, y is 7. When x is 2, y is 1. When x is 4. So don't freak out if you see this table. It's the same exact thing. So we're going to look at points in a table which fall on a line. So that's our whole goal. If you can keep that all straight, you're going to be in business. We'll be good to go. Fantastic. Let's try to tie it together some more here. Next slide, please. All right, let's look at a word problem real quick here. Check it out. It says Sarah has 2 baseball cards. Each day she collects 3 more cards. So we've kind of been toying with this idea of like writing a rule or writing an equation. That's what I'd like to do here. I'd like to go from this verbal expression to an equation. So how am I going to do that? Well, we're looking for 2 things. We're looking for initial value and rate of change. So when I look for this, what does Sarah have? What does she start with? Well, Sarah, first sentence, Sarah has 2 baseball cards. So she has 2 cards. Then what's happening? So that's her initial value. She starts with 2 cards. So we know she has 2 cards. Then we've got some kind of rate of change. What is changing? What is adding or subtracting? Well, every day or each day she gets 3 more cards. So I'm going to say she has 2 cards plus every day she gets 3 more cards. So it would be 3 cards every day x. So really the rate of change in this case would be 3 cards per day. Fantastic. So excellent. That's what we'd like to get to is can I take this verbal and make an equation? But let's say I couldn't. Could I just straight up fill in the table? Even if I couldn't write the equation, sure, I got these 2 variables. So what are my 2 variables, my unknowns? Well, I know baseball cards, and the other thing is time. In this case, when I read this, it says she has 2 cards, plus she gets 3 cards every x. What is x then? X is usually this first column here, and in this case, it stands for time. So we're going to say it is time. So that's what x is, and that's the label. How about, what's its unit? What is it measured? Is it months, weeks, years, centuries? Well, in this case, we're saying every day, so we're going to say the unit is actually in days. So we're measuring time in days. And then, so as x is changing, it's changing my y over here. So this is my y column. And what is y then? Y has got to be his baseball cards, or her baseball cards, her card collection. And the unit in this case is just, we're counting numbers is all it is, the number of cards in her collection. So when I do this, can I fill in the table? At day 0, how many cards does Sarah have? She has 2 cards. Excellent, because she started with it. If you check it out, that's my initial value right there. On day 0, she has 2 cards. After 1 day, she gets 3 more cards, so she has a total of 5 cards. After 2 days, what happens? She gets 3 more cards, she's at 8. 3 days, 3 more cards, she's at 11. And maybe you can notice that there's a pattern here. What's happening every time? Well, we're adding 3, plus 3, plus 3, plus 3, or really that's the rate of change. How much is it changing each time? So what would I do then if I wanted day 20? I know it's not in your notes, but you can add it in there. Let's say I'm very curious about day 20. Well, what am I going to do? Are you going to keep this pattern going? Plus 3, plus 3, plus 3, plus 3, plus 3, plus 3. You could, sure, no worries. You could do that if you wanted. Or I could say, well, I know my equation is y equals 2 plus 3x. X stands for the days, so I'm going to put in 20 as my days. So really I'm going to say 2 plus 3 times 20. And I want to know what is y when x is 20. So if I solve this, I get what? 3 times 20 is 60, plus 2 is 62. So really day 20 is going to make 62. 62 cards on day 20. Fantastic. So now can I take that and make it into a graph? Sure. These are just points. Remember, this table is just points. The first point is 0, 2. The next one is 1, 5. Next one, 2, 8. just plot these points on here. So the first one, go over 0 up 2, put a dot. That's the first one. Then go the next one, 1 up 5 is going to be something like this. And then over 2 up 8, something like this. Draw in your line to connect the dots. Use a nice ruler or straight edge to get that going. And you should be good to go. Very good. Let's check this out. Another thing we're going to have to be able to do is this a solution? So is the 0.58 a solution to this equation? So we're looking for a yes or no. Well, how do I check it? Well, this is just the point x comma y. So really I'm saying, is this point on the line? Well, let's check it out. If x is 5, I'll replace x with 5 plus 3 over here, and y is 8. Is this true? Does 8 equal negative 2 times 5 plus 3? Let's work it out. Negative 2 times 5 is negative 10. Plus 3, does 8 equal this? No, that looks like negative 7, doesn't it? No, this is not the case. No, so this is not a solution to this. 8 does not equal negative 7, so it's not a solution. So this point would not be on the line. Same thing, I kind of threw these on here. If I just asked you to graph this line, you could graph and see is 5, 8 on there. You can go ahead and try to fill in this table on your own if you like. And see how that goes. I'm going to go ahead and do it real quick. So pause if you want to try and then you can see the answers. Here we go. I'm going to plug them in. If x is 0, so this is my x's and my y's. So really I'm looking at what is y when x is 0. And this is nice and friendly because 0 times anything is just 0 plus the 3. So I know this. And again, this would be my initial value. I started with 3 of something. 3 apples, 3 oranges, 3 pies. I don't care what it is. They started with 3. And then let's put in 1. If you put in 1 into this equation, negative 2 times 1 plus 3. So I'm saying this is really negative 2 plus 3 is 1. So this looks like 1. And maybe you notice the rate of change. It's just going down 2. Or keep plugging and chugging, but this should be negative 1. This should be negative 3, negative 5, and negative 7. Excellent. Could I plot all these points? Sure, no problem. Start at here. 0, negative 3. It looks like I'm at 1. I'm at 1. At 2, I'm at negative 1. At 3, I'm at negative 3. At 4, I'm at negative 5. Am I in the right? 1, 2, 3, 4, 5. There we go. And at 5, I'm at negative 7. So you can see here comes my line. If I can draw a nice straight line. And oh my goodness gracious, did I miss that line? Holy cow, let's do this. Even that isn't very good. Hopefully your lines. Get a ruler. Definitely got to get a ruler for these. Put it in. There it is. Now I hit it. So you can see, was that original 0.58 on there? Well, if I go over 5, up 8, there's no way it's on there. 1, 2, 3, 4, 5, up 8. It's this point. Not even close to being a solution or a point on the line. So definitely not a point on the line. Excellent. In the finale here, what if I just give you the graph? No equation. Can you still fill in the table? Sure, these are just points. So go over negative 3, 1, 2, 3. And what's the y value here? We're down 1, 2, 3, 4. So it looks like negative 3 makes negative 4. How about negative 2? Sure thing. I'll go back 2, down. This looks like down 2. At negative 1, I'm right here at 0. At 0, I'm up at 2. So these are just points. At 1, I'm up 1, 2, 3, 4. And over 2, up 1, 2, 3, 4, 5, 6. And again, maybe you can see your initial value. You started here with initial value of 2 something, and what's the rate of change? I don't know. Maybe you started with 2 pies, you make 2 pies every day. So it all kind of blends together there. Excellent. Good luck on the homework. Peace.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 1, 1, 1.